Hello, my name is Alfonso Bernal. The topic of this video is exponents. In this video, we will review the concept of the product rule for exponents. So let's get started. So let's consider the product rule for exponents. The product rule for exponents says the following. For any real number represented by the letter B and integers represented by the letter M and the letter N, we can say the following. B raised to the power of M multiplied by B raised to the power N is equal to B raised to the power of M plus N. In other words, when you have a product of two bases, you keep the same common base and you add the exponents. And this is the product rule. Let's consider an example. Suppose you have 3 raised to the power of 2 multiplied by 3 raised to the power of 4. By the product rule for exponents, this is then equal to 3 raised to the power of 2 plus 4, which equals 3 raised to the power of 6. In turn, this equals the repeated multiplication of 3 6 times. If we evaluate this product, this equals 729. So now, let's practice this concept of the product rule, which says that the product of two bases is equal to the same base raised to the sum of their powers. So let's evaluate the following expressions. The first expression reads 4 raised to the power of 2 multiplied by 4 raised to the power of 3. Using the product rule, this equals 4 raised to the power of 2 plus 3, which equals 4 raised to the power of 5. In turn, this equals to the repeated multiplication of 4 5 times. So let's evaluate this product. If we multiply the first two numbers together, we will get 16. If we multiply the following two numbers together, this also gives us 16. We can then multiply the 16s together. And at the very end, we will then multiply by the last 4. Multiplying the 16s together, we will get 256, which is still being multiplied by 4. Multiplying 256 times 4 will give us 1024. So for this first expression, the result is 1024. So now let's evaluate the second expression. The second expression reads 3 multiplied by x raised to the power of 2 multiplied by 6 times x raised to the power of 7. We could first rewrite this expression by multiplying the coefficients together and then multiplying the variables together. When multiplying the coefficients together, this will give us 18. When multiplying the variables together, we can use the product rule. Using the product rule, we will get x raised to the power of 2 plus 7. And so this equals to 18 multiplied by x raised to the power of 9. And that's the result of the second expression. Now let's look at the third expression. The third expression reads x raised to the power of 2 also known as x squared, multiplied by a parentheses containing 3x plus 4x squared. An important note to make: 3x represents 3x raised to the power of 1. To evaluate this product, we will need to distribute the x squared into the parentheses. And so, let's go ahead and multiply x squared by the first term in the parentheses. This will equal 3x squared multiplied by x raised to the power of 1. Note, in this product, the variables are grouped together. Next, we need to multiply x squared by the second term in the parentheses. And so, we will write plus 4 multiplied by x squared times x squared. Again, grouping the variables together. Now we can further simplify this expression by using the product rule. This expression is then equal to 3 multiplied by x raised to the power of 2 plus 1 plus 4 multiplied by x raised to the power of 2 plus 2, which equals 3x raised to the power of 3, also known as x cubed, plus 4 multiplied by x raised to the power of 4. And this represents the result of the third expression. Note, 3x cubed and 4x raised to the power of 4 are not like terms. This means we cannot add these terms together. Recall, like terms have to have the same base and the same power.